Hello everyone, I'm Andrew Pramar, and in this lesson, we're going to talk about object-oriented programming. So far, you've learned about operators, conditions, loops, and even writing functions. These are all real powerful tools that you can use to write some neat programs. We're going to expand on these fundamentals and see how we can write code that is actually reusable. So for this video, we have decided to open up a mini bank for our neighborhood. People really trust us with their money, and they want to keep their money safe with us. And being good bankers, we know that bookkeeping is probably the most important thing we can do, and that's a good bookkeeping. So let's see if actually Python can help us with this. So what we need is a way to keep an account for each customer, and each account should have information about the client's contact information and account balance. Additionally, when money is deposited or withdrawn, we need to be able to update our books to reflect the appropriate change. So I've gone ahead and I've created a dictionary with information about our first three customers. For each customer, we have their name, email, and balance. I can view John's balance by printing printing John's balance here. All right, so let's just go ahead and print that. Okay, and run, and there you go, right? So you're seeing that John's balance is showing up as 1,000. Now, if John decides to make a withdrawal, I can very easily change like that. Let's try again. Oh, there we are. I can very easily subtract 500 from John's original balance and then print the remaining. Well, likewise, I can also do that for Mary. So if I were to uncomment this and save and run again, here we see that Mary first started off with 3,000 and now she's at 3,500. Now, while this seems pretty simple, we can see that this is getting pretty repetitive. I mean, what if I make a mistake? What if each time there's a transaction made and I need to ensure that if it's a deposit, it's an addition, and if it's a withdrawal, it's a subtraction. What if I flip those around? You see? So this is where having to write code over and over again is a disadvantage. Now, can I somehow make a template where I can add new customers and make sure that deposits and withdrawals are handled exactly the same way each time? If we could do that, that would really help our case here. And it just so happens that object-oriented programming is the perfect solution. So I've gone ahead and cleared my screen. Now we can go ahead and start building our customer blueprint. To start off with, let's define what we want our customer blueprint to be. So I'm going to go ahead and say that for each customer, we need these 3 bits of information. We want their name, email, and balance. And in terms of operations that we can perform on this customer account, it's going to be withdraw and deposit. I want to go ahead and call our blueprint customer to keep it simple. And in Python, the way you define a blueprint is by defining a class. So a class is a blueprint example of the object that we want to create. To change my wish list here into a class, I'm going to do the following. I'm first going to add the class in front of customer, and I'm also going to add object here, after which I'm going to add self.name under these 3 items. These are my variables that I need initialized as soon as my customer object is called. So in order to do that, I'm going to move all of these out, including that guy, and put them under a special method called the init method, which takes a unique argument called self, which is nothing but the object itself. We also have the name, the email, and the balance. And all of these need to get bumped up. And then each one of these gets assigned to name, email, and balance. Our operations then become these special functions that we call methods. So when you create a function within a class, it is called a method. Okay, and my withdraw can do the following. It takes again self and amount to withdraw, and all it does is it takes the balance from up above and subtracts the amount. Likewise for deposit, we define our deposit as self and amount self to balance. We add the amount to your balance. With our blueprint ready, we are now ready to make objects. I've gone ahead and created 3 objects called John, Jill, and Mary, and each one of these is an instance or made out of the customer blueprint. And you'll notice here that each one also now has John, the name, john@email.com, and the account balance inputted into the class being called, right? And that's customer right there. Likewise for Jill and for Mary, the class is being called and the appropriate name, email address, and amount has been added in there. I can reference John's balance directly by typing in john.balance, and I can also withdraw from John's account by directly calling the method that we define, withdraw. In this case, I'm going to go ahead and withdraw $2,000. And then lastly, we're going to go ahead and print John's balance again so we can see the before and after. Okay, if I save this and if I, okay, it's giving me a syntax error, so I have definitely forgotten something there. And that needs to end with semicolon, or colon actually, and save it again. And I'm getting an error here. Fix that right. I'm going ahead and fix those extra space errors that was causing a program to fail. So now with this all ready, I can go ahead and execute this. As you can see, it's showing me that John's first balance was $1,000. We then go ahead and withdraw $2,000, and then John's ending balance is again negative $1,000. Well, so far so good. Now, what if we wanted to make sure that no customer could withdraw an amount of money that was greater than their account balance? Well, we can now that we have our blueprint defined, we can go ahead and go back to our withdraw function and put in a little bit of logic that allows us to do exactly that. We're now going to come in here and check that if the amount that we're trying to withdraw is greater than the object's balance, in this case the customer's balance, we can then go ahead and print insufficient funds. And if that is not the case, if this conditional is not true, then we can just go ahead and make the deduction. Okay, running this program the second time now tells me that when I go ahead and try to withdraw $2,000, it's letting me know that there is insufficient funds. So that's why John's before and after are exactly the same. So this gets 1,000 and then 1,000 again. With our class in place, we can now build a system that interacts with objects created using the class blueprint. Let's go ahead and create a new function. Let's call that main. And in this main function, we're going to create a customer list. This is going to house every single customer that we have within our bank. And what we're going to do is to start off with, we're going to add three different customers, John, Jill, and Mary. And we're just going to go ahead and append it to the customer list. Next, we're going to add a function that shows us all our customers and their balance information. I'm going to add that here. We're going to call this the show all customers function. All it does is it takes the customer list right there, and then it prints out every single customer and the customer's balance. And the end, it also has the added option that it shows us the total amount of money within the bank. Next, we are going to add two new functions that will allow our bank system to pick a customer's account and make the necessary transactions. Here you see we've added the account deposit, which asks the bank teller to pick the account that they are trying to edit and then input the deposit amount. Likewise, there's the account withdrawal function, which again asks the bank teller to enter the customer's name that they are trying to, whose account they're trying to edit, and then enter the withdrawal amount. Lastly, in our main function, we are also going to allow the operator to make a selection based on this quick menu that we're creating. We are calling this the bank mini bank teller terminal, and in that we have four different options: show all customers, new customers, make deposit, and make withdrawal. And each of these options, depending on the input that the teller puts in, calls on one of these four functions that we've defined: the show all customers, account deposit, account withdraw, as well as the very first one, the second one, which is nothing but creating a new customer. Okay. Lastly, we're going to go ahead and add the function to start this. I'm going to save this and run. Okay. So what do we have here? This is our mini bank teller terminal. Now, if I wanted to view all our customers, I could hit 1 and enter. And it's showing me now that I have John, Jill, and Mary. And for each one of them, there's 1,000, 2,000, 3,000, respectively. And our total bank holdings is 6,000. Great stuff. We're back at our mini bank teller terminal. So the while loop makes sure that each time our option is inputted, we do the necessary operations, and then we come right back to the option input make selection field again. All right, so let's go ahead and add a new customer. I'm going to add a new customer. This customer's name is going to be Jack. That's Jack. And then Jack's email is jack@email.com. And Jack's starting balance is going to be $6,000. All right, so let's see if Jack was in our system. As you can see, Jack has now been added to our mini bank, and the total bank holdings have risen to $12,000. I think we are doing great. Okay, so let's go ahead and make a deposit in Mary's account. So let's do make a deposit, which is 3, and the customer we're trying to edit is Mary. And the amount we're trying to deposit is $300. Okay, so Mary's new balance is $3,300. I am noticing that we have Mary, Jill, and John showing up, which probably means that we have a print statement here that is executing. And I believe that one is there. So that was just my test print statement. And I can go ahead and silence that guy. So the next time around we start this, we're not going to see that in anymore. Okay. Great stuff. Let's try making a withdrawal. So I'm going to go ahead and say 4. and the customer we're trying to withdraw from. So Jack, since Jack has a lot of money, we're going to go ahead and withdraw Jack's account in the amount of $3,000. Actually, let's do $7,000. And as you can see, there is insufficient funds, so Jack's new balance is still the same. It's $6,000. Okay, and there you have it. You have effectively written your very first fully functional object-oriented program, and I hope this was fun. And play around with it. Try to add some more functionality to the classes so that your withdraw and deposits are a little fancier. You can put in more logic. So, for example, you can only withdraw if the funds are above a certain amount, or you always need to keep, so you can ensure that there's always a minimum balance. Likewise, you can also make sure that when you are depositing, there's a certain amount above which you can't exceed, right? And again, feel free to keep adding more items, and this is it. So thank you very much, and I hope you enjoyed this one. You have a good one.